Hi, welcome in another video. In this video specifically, we are going to solve the past paper question, which is about the Newton's first law of motion. So Newton's first law of motion is applied to those type of objects which are either at rest or they are moving with a constant velocity. Well, in this question, they do not mention any change in the direction, and they specifically mention that the two boxes are moving at a constant speed. But the point is, it is another confusing point that you are applying a force, but despite of it, why they are moving at a constant speed, and secondly, the speed of the both blocks is same. All right, which means that they are moving as a one system. So this is a small block and this is a two times heavier block. All right. Now, if they are moving as a system in this direction with a constant velocity, so on this system, which is a system of two masses, right, and their combined mass is m plus 2m is equals to 3m. So the force F is applied on this system of blocks, but why it is still moving with a constant speed? And that is due to some resistive force. And most probably, they do not mention which what is the nature of that resistive force, but most probably, in most of the cases, this force would be the frictional force, right? That is applied by the surface. Okay, so this question is so easy. They are asking about the resultant force acting on y. Since the resultant force of a system, the net force of a system is zero, because the F is opposed by some countering force. So even on this y, if you draw the free body diagram of this y, so this force is applied by the x on y. Okay, and this force is applied by the surface of the table, and this force is applied by the weight, the gravity. Okay, so dear students, this is the resultant force. That's why we can say it is 2ma. So when it is 2ma, since I said the net force is zero, so what is the acceleration of a system? That is also zero. So obviously there is a no force, so the right answer is A. But don't go anywhere, I will tell you exactly what is the retarding force and how is it proportional. Okay, because we know that overall the force on this system is applied to the right. And what about the other forces inside the system? Dear students, this force is the weight of this m, and this force is a normal force. It has a larger weight, so that's why it has a larger normal force. Both are equal. And what about the contact forces? This is the contact force applied by the m on 2m, the same contact force applied by the 2m on m, right? Now the other, like, these are all internal forces which are balanced with each other. Now let's talk about how, what is the retarding force? Since the resultant force is zero, and this retarding force is proportional to the weight, or in other words, we can say it proportional to the mass of the block. So, for example, if you want to know how much is the retarding force applied on the y, so just keep the 2m, the mass of the y, in numerator, and in denominator, I'm going to add these two and multiplied by the force F. Okay, because I want to know what proportion of F, or what part of F is the countering force. I hope you understand. So it will come out 2m over 3m into F. So dear students, we see 2f over 3. It means that the 2f over 3 is the force which might be a frictional force. They do not mention here. So this is 2f over 3. And in the same manner, on x it should be on the same logic, right? It should be m over 3m times f. So that is obviously f over 3. And if you count, if you add the 2f over 3 and f over 3, you will get the f, which is exactly opposite of, yeah. So this is f over 3. So now you understand that this f over 3 plus 2f over 3 is basically opposing the f, and hence making the overall resultant force 0, and resultant acceleration is also 0. I hope you understand, and let me know in the comment.